First of all, even before getting into the presentation, I want to clarify something, and it's that some of you might be a bit puzzled by the fact that the title on the presentation is a bit different. You're in the right presentation, I hope. It's just that when I was building the slides for this presentation, I realized that the title of the talk was a bit long for a slide. So you're in the data stream to prediction, how to build machine learning data pipelines and deploying them into production. Just in case you are wondering what happened with the title and am I in the right presentation or in the right talk? I hope you are. So with that, who am I and what I'm doing here today? I'm Carles Arnal, and I've been building at Red Hat/IBM. For those of you who don't know, IBM bought Red Hat a few years ago. So I've been at both companies at this point for 6 years. I'm a principal software engineer at IBM, and I work on Apicurio Registry, which is an fully open source project. We practice the open principle by upstream first, and then we, of course, build products. We all need to make money, right? But then we publish our code and we build our projects. Today, I'm going to show you how to build a real-time content classification pipeline using only open source technology. Apicurio Registry is going to be one of those tools, but there are going to be obviously more tools being used, and everything running entirely on Kubernetes. To be more specific, I'm going to deploy everything on Minikube, but you can deploy all of this in GKE, AWS, in any Kubernetes provider of your choice or preference. There is no strict need for any of them. We'll go from the raw text, and I'll get to that in a moment, to live dashboards with data and some graphics, and I'll deploy the whole thing live, and I hope that the demo gods are with us today, because it's going to be a live demo on a stage today. So we're going to get started. What kind of problem are we trying to solve? So this problem is a problem that is basically everywhere today. It's a problem that in finance you need to do fraud detection, for instance, and on transactions as they happen. You can't wait for an highly batch job to detect the fraud in a transaction. That needs to happen immediately. In social media, obviously, content moderation is another example of this that needs to happen immediately, and in milliseconds or microseconds. It cannot wait hours or days for that moderation. And obviously, trend detection needs to happen in seconds as well, not just in hours. And obviously, in cybersecurity, as we have here, threat detection and classification has to happen immediately as well, not just in hours. It has to be instantaneous. The common pattern across these all use cases is the same. Data arrives continuously, flows continuously, and then you need to classify that data in real time. You need to treat that data and classify it, not in a batch. And the challenge we are going to face is in just running a model. It's building a reliable pipeline around the model. So this is not going to be focused. We are going to be talking about models a little bit, but this is not just around the models. Models, in this case, are just a tech choice rather than the focus of the presentation. So the challenge, as I was saying, you need data ingestion, you need a schema contract, you need inference, you have analytics, monitoring. Each one of those things on its own, it's a distributed systems problem. A big challenge on its own. And I'm going to try to show you how to wire all of them together using only open source technologies in this presentation. The case study I'm going to use, it's a case study I've been using in purpose for this presentation. I'm going to use a very concrete one, and it's classifying Reddit post from a very concrete subreddit called Ask Europe. For those of you who don't know, it's a regular place where you can ask questions. There are lots of discussions around a million different topics. And I'm going to use the flare categories. Think of flares in subreddits as simply categories. Treat them as categories for the sake of this presentation. So you're going to have things like travel, politics, food, economics, miscellaneous, media, all those different things. Okay. Why Reddit? Why this case study for this presentation? It's messy. It's as simple as that. It's the most complex thing, and the most complex text is human beings writing text. It's the closest thing to think of Twitter or X these days, and the text that humans are writing on there. But the nice thing about this subreddit is that although posts are wildly informal. They mix languages. They have slang and abbreviations, and they have lots of noise. There are data for those who read that still has the label, the category in the post. So we can use that for training the models, and I'm going to show that in a moment. And let me move to the architecture. So this is the full and the entire architecture we are going to discuss. You're going to see here a CSV data, and there is an explanation for this. At this presentation, up until last week, was supposed to be streaming data from the Reddit API, but that has changed because they changed the API, and now you need a subscription, on a developer subscription on their end. So now I had to use the data I already had for my presentation for training the models. Excuse me, but I'm faking the data streaming side of things from the Reddit API. And I have the CSVs data. I'm going to have a process that is going to be processing those CSVs. It's going to be sending that data process to Kafka, let me look at the name, to the Reddit stream topic. And in parallel, Spark Structured Streaming, that you have that part in here, is going to pick up those messages in micro batches and run the two machine learning models that we are going to discuss in a moment in parallel. One is a transformer model, and the other one is a scikit-learn classifier. Both predictions, along with confidence scores, going to a second Kafka topic here called Kafka predictions. And then we are going to have a Quarkus application that is going to read those predictions from the Kafka topic and is going to build the dashboards and offer the statistics and the dashboards around these things. The key here is that the two machine learning models are going to be running in parallel. One of the models that we have is a DistilRoBERTa, is a transformer. We are all surrounded by transformers these days in machine learning, right? So this is going to be a transformer model. And then we are going to have a classic old logistic regression model with a TF-IDF and LSA. We're going to compare both models and see which one gives us better insight or a richer insight. We are going to discuss things like agreement rates, uncertainty zones, confusion matrices, and all those things for those of you who are into a little bit into data science. All of this, obviously, without needing any ground truth labels. So as you can see here, one of the project I said I'm involved with, Apicurio Registry, is in the middle here, and you might be wondering what's the role of this project in this entire presentation. Essentially, we are going to have two schemas for the producer side of things. The Kafka producer that you see here, where it says Python, it's going to use a particular Kafka schema. A particular schema is a JSON schema. And it's going to use that schema to format the data that is going to be sending to the Reddit stream topic. And on the other hand, the Quarkus consumer is going to ensure that the data is consuming also adheres to the same schema. What's the point of that? Schema evolution. If you have a producer that has changed and now has a different field and it's breaking your producer, you're preventing your data from getting into the topic, and you're preventing your data from being corrupted and from corrupting your dashboards at the end. We are going to see that as well later in the presentation. This entire pipeline, and I'm going to show you that later, is deployed on Minikube on my laptop, and you can deploy that anywhere you please. Getting a bit more deep, let's talk a little bit about the machine learning models. I have spoiled a little bit that we're going to be use a transformer model and a bit more classical model. So let me move to the next slide. The two machine learning, the two models that we're going to use. On the left, we have the transformer model. It's a fine-tuned DistilRoBERTa model. It's a distilled version of Roberta with about 82 million parameters. It has 6 layers, 12 attention heads, and 768 hidden dimensions. Lots of numbers for these things, right? If you're not into this thing, you don't need to worry too much about this kind of information. It's information for those of you who are into the machine learning side of things. The important part is that I have fine-tuned this model with label data from the subreddit Ask Europe. Fine-tuning, for those of you who don't know, we can discuss at the end. Fine-tuning is essentially you have a general purpose model and then you adapt it to your data. We can discuss that a bit later. Now it's a very trendy technique and technology, obviously. So why this model in particular, not another model? It's simply because it's good enough for this real-time classification problem. The accuracy is not going to be the best in the world, but it's good enough for the simplicity of the presentation and of the demo. And for this kind of a streaming pipeline, latency is what matters most, and this model is really, really small and can run, as you're going to see, in a laptop. For example, this model understands what a sentence means, not just what words appear in it. A post that says, I visited my grandmother in Krakow and she made pierogi, the transformer understands that's about food and travel, and it can, with the context, to decide whether it falls under one category or the other, and which flair fits it best. And on the other hand, the back-of-word model will see Krakow and pierogi as independent signals. So the transformer sees the entire story, not just the two signals on both sides. And on the right, we have the scikit-learn model. This is a much simpler pipeline. TF-IDF vectorization to convert into numerical features, then truncate those features, also known as LSA, latent semantic analysis, for dimensionality reduction, and finally, logistic regression as the classifier of the text. It captures the term frequency patterns, and it cares about which words appear and how often. Really, that's mostly about it when it comes to this model and its classification. It's fast, it's lightweight. Inference takes microseconds in this case instead of milliseconds in the case of the transformer model. So low numbers still, but microseconds instead of milliseconds. So, and one of the important things about this kind of model is that it produces well-calibrated probabilities, which means that the confidence scores are more spread across the entire distribution. You're going to get confidences that might be 0.9 and also confidences that might be 0.3. You're going to get that. On the other hand, and if you are used on transformers, you are going to mostly get confidences around 0.9, 0.92. It's very confident about the prediction that is doing the transformer model. Very, very confident. So both models have been trained based on the same data set, about 30,000 posts from the Ask Europe subreddit, and those already had the flares assigned to those posts. So that's why I used this as the case study. The transformer ended up achieving around 65% accuracy, which is not great, obviously, and the SKLane model around 55. Again, not spectacular, for sure. But we have 13 categories with noisy, very informal text, and this, if you haven't worked with this kind of problem, it's a very hard problem to deal with and to treat. So a random baseline will give you around 7.7% just for the sake of it. So some of those categories are inherently ambiguous, as like the examples I post, or another one will be, what about a post about Italian food? If you are not Italian, obviously, and you don't live in Italy, is that about travel or food? What category is that post about, right? So there are some categories that are inherently ambiguous. So at the end, both models output two things: the predicted flair, obviously, the thing that we care the most, and also for statistics and for building our dashboards, the confidence score of the model between 0 and 1. Now, another interesting part of this thing and this whole idea. Why running two models? Why? There is just one reason. The agreement rate between the two models is going to act as a proxy for prediction reliability. What that means? When both models agree, we can be obviously more confident that the prediction is correct, so we can normally, obviously, act autonomously on that prediction. That's the end goal of this thing. On the other hand, when they disagree, that's a flag that the post is ambiguous or unusual, as I was saying with the Italian food example, correct? And we get all these insights without any ground level of the data, without doing anything. You have your data set trained, but then you are running on untrained data, on unlabeled data, And you get the same, you get all that information from that data just by running these two models. This idea is called as a supervision signal. It's related to ensemble methods and co-training in machine learning model literature. But here we are not ensembling them to improve accuracy in the models. Okay, we are using this just as an observability tool, and we are going to get that into that in a moment. That's the key insight. Observability about the data and about the things, not really about improving the accuracy of the models themselves in this case. And now let me move to the next slide here. Schema governance. Before we get to the live demo, that's the next part after this part here. Let's talk a little bit about the schema governance, because in any data pipeline, for those of you who've been involved with this kind of things, we have very complex technologies, we have models, we have lots of stuff. Someone has added a field in a schema in some pipeline, and the pipeline has broke entirely just because of that. That's the most common error, the most common thing of waking someone up at 3 a.m. That's at least in my experience, that's the thing I face the most. So, what can we do to improve this thing? Data contracts between the pipeline components. This is where the project I work in the open community comes in. Before any data flows through your pipeline, we need to define contracts, schemas in general. Okay. In this case, we register JSON schemas. Those are the two schemas that we are going to use during the demo and during the presentation. We register those JSON schemas in Apicurio Registry for each Kafka topic. And if you work with microservices, I guess at this point everyone worked with microservices at some point on their career, right? I mean, we all been through this at some point. So, if you work with microservices, you for sure know this pattern. It's the same idea as an open API spec for a REST API, but for event-driven systems. The schema is the contract between the producer and the consumer, and if someone breaks that contract, you want to know that before the data flows and not after. So we have these two schemas. The first one is the ready stream value, is the schema that is going to be used for the output of the producer. It has an ID field and the content, essentially the ID of the post and the content of the post by the user. And the second one defines the inference output of the two models. We have the ID of this inference instance, so to speak, and then we have the transformation, the transformer flare, the flare inference by the transformer, the confidence by the transformer, the flare by the scalar model, and the flare by the confidence, excuse me, by the scalar model. So what does this do? This prevents schema drift. If someone changes the producer here to add the new field, remove a field, or change the data type, the downstream consumers won't silently break. The consumer won't consume that data. It won't be able to consume that data. It will continue to consume your data, the data that adheres to the schema that it's supposed to consume, but it won't consume that data. You have a contract now between your producer and your consumer, right? So the schema validation will fail, and in our pipeline, that's what happens. Something changes, it's going to break. Other things that you have to prevent, even the addition of a malicious field or something from happening in your schema, Apicurio Registry also supports what we call rules. You have backward and forward and full compatibility rules for your schemas, meaning that if you, because JSON schema is supported, protobuf is supported, Avro is supported, multiple schema types are supported. All those comes with rules when it comes to add or remove fields, or what you can do or what you cannot do with them. So we have implemented rules, the rules in the server for that. So if you try to remove a field from an Avro schema, for instance, that change is going to be rejected, basically, if you have that rule enabled, right? So you're not going to even get to the producer if you have those rules enabled in your application. And as I was saying, we support multiple schema types. I don't want to get now into the details. We support multiple of them. Now, let me go to the Apicurio Registry UI. I'm going to get out of the presentation here a little bit. This is how the UI looks like. We support what's known as groups. It's just to group your information. And here we have the schemas I was describing. Those are the schemas that we have in the presentation: the Kafka predictions and the Reddit stream. When you go to this one here, you are going to see, just in a moment, you are going to see here that this has a version, and the version 1, obviously because I just registered one version for this schema, you're going to see the content of this. And here you're going to see the JSON schema that I was describing. Obviously in the presentation it's way simplified, but it's exactly the same thing. You got the transformer flare, the confidence, the flare for the logistic regression model, and also the confidence. Same for the producer side of things. If I go here, you're going to see exactly the same thing: the type, the content, and the ID, and here the type of the field and everything, and the required fields. This adheres to JSON schema and follows the JSON schema validation rules. I just wanted to show a little bit the user interface of the server. So that's it. Now let's get into the most interesting part of the presentation, the live demo. I have everything pre-deployed except for a couple of things, obviously, and in a moment you're going to understand why. Everything can be deployed in Minikube and in a laptop, but it takes time. So we have a limited time for this presentation, okay? But first, here, what you see here in this presentation, and you might be wondering what's happening here, it's a live terminal embedded in the browser and inside the presentation. So it's working. This is connected to my laptop. This terminal is connected to my laptop, and what you can see here is what I already have running. So what you see here, I have the Reddit real-time namespace and the Spark operator namespace. As I was discussing, we have a Spark here up and running. What do we have in the Reddit real-time namespace? It's the Apicurio Registry server, this one here, this guy here. Then we have the Apicurio Registry user interface. They are separate pods and separate applications. Then we have the Quarkus consumer, the Quarkus application, the one that is getting the inference results from the Kafka topic and publishing the dashboards and the statistics. And then let me start with this one, actually. This is the StreamC cluster operator. This is StreamC. StreamC, essentially, for those of you who don't know, it's an operator that allows you to deploy Kafka on Kubernetes. It makes it way, way easier, as simple as just defining a YAML and deploying in your Kubernetes cluster. So, and what you see here is the actual broker for Kafka in this case. This is Kafka 4, so no zookeeper, no things that are not really needed for this case. This is it for this side of things. And on the Reddit side of things, you obviously see the operator and the controller. You see the driver, and here you see the two executors that I have for Spark. Okay, that's mostly about what we have deployed here in the presentation. The only missing piece, as I was saying, is the producer. So let's get to the next slide, and let's deploy. This is not. No. Let's deploy the producer. I have created the producer, and now, in the second terminal, let me tail the logs of the producer. This has started, and it has started producing, as I was saying at the beginning. Now, unfortunately, it's a CSV with the data. It was supposed to be taking data from the Reddit API. It is what it is. So what you see here is messages from the Spark producer. It's messy because I was debugging some things last week for obvious reasons. But you can see here that it's sending information to the Reddit stream topic, and it says the partition that is using and also the offset that is using for sending those messages. And this is going to be continuously sending data over the presentation. So there is no point on sticking here. And now, let me get back because move this part here. If I do this here, this is going to connect to the Quarkus application because if Spark has processed, and I hope so, because I'm seeing that on the other side, if Spark has processed all the information, it's going to load the statistics that the Quarkus application is building based on all the data that has been flowing through Spark to Quarkus, and Kafka and Quarkus. And now, I hope it's big enough to be seen. You don't need to get into the details of all the different things, but you're going to see a few things here. Here you see basically a JSON that I used as a summary. And we can see here per flare counts in this part here. You can see at the beginning of this JSON object, you can see the number of posts that have been classified under a specific flare. You can see also the average confidence for that category. You can see the average confidence for the transformer, for the logistic regression model, the agreement rate between the two different models for that category, and also the confidence gap between the two models. Okay, and this is very interesting, but this is a JSON. We are going to get to dashboards in a moment where we can see the things. Okay. Now we have everything. You have seen the data flowing from one side to the other side. The entire pipeline is working end to end. CSV, I'm sorry. So the producer is cleaning that is cleaning the information, is validating the data using the schemas as I have described in Apicurio Registry, is publishing the data picked up by Spark, running both machine learning models, inference on both models, and publishing the predictions to the second Kafka topic that I was discussing earlier, and then that gets consumed by the Quarkus application. And it gets aggregated, as you can see this, into real-time statistics. Those are statistics, if you run that, as you can see, the producer is still running. So if you run that command again, the statistics are going to change, obviously. Okay? Now, another important part, not just for this presentation, but for any presentation in general. How does this work? It's an important part about any presentation or any demo in general. The data is still flowing in the background, as I was saying, and every post that you see in those logs, in the producer logs, is going through the full pipeline right now. It's going from the CSV. I'm faking the real-time thing in the CSV. It's processing the post, but it's flowing through the entire pipeline. Let me explain what's happening at every one of those stages. If you want to see the code, you're going to get that opportunity at the end because it's published on GitHub. So if you're wondering about that, don't worry. You're going to get the code and you're going to get everything, even the YAMLs for the deployment into Kubernetes. So this part here. What's happening? What's happening here? What's the first step? Collect and clean. The producer is reading the pre-collected Reddit post, as I was saying, from the CSV files, and each one of the posts is going through a cleaning pipeline, where it's stripping out things that don't matter for this kind of problem, of classification problem, like URLs, removing stop words, remove punctuation. You know what that is when you are dealing with text and when you are treating that kind of information, right? You are concatenating the title, body, comments, any content that gets into that post. You are processing excuse me. You are processing that information, so you are able to do inference into that using that content. Okay, so that gives the model a clean and unique input, not multiple scattered inputs. We are validating and streaming all the information, and before any message goes to Kafka, is validated against the JSON schema that is stored in Apicurio Registry, using the Apicurio Registry serializer, and only valid messages make it to the Reddit stream topic. At this point, if I did everything correctly, and I hope so, all the messages are valid right now. All the messages that are flowing are supposed to be valid. Okay. Stage 3, as we were discussing, dual inference, Spark Structured Streaming is picking up the messages from the Kafka topic in micro batches, and for each post is running the two models in parallel inside PySpark and using UDF. The transformer is tokenizing the text, it runs a forward pass through the entire neural network, and applies the softmax to get the distinct probabilities for the categories. Then, on the other hand, the logistic regression model is running the TF-IDF technique, is applying LSA for dimensionality reduction, and it's classifying the post using logistic regression. And both outputs, the predicted category or flare, and obviously the confidence score, because we need that for the statistics, is going into the Kafka predictions topic. And last but not least, because I think it's one of the most important parts of this presentation, we need to consume the information and analyze the information. This is, I think this last part is where human beings are going to be way more important in the future than they've been even more than they've been in the past. The Quarkus application is consuming the information from the Kafka predictions topic using a framework from the Quarkus team. It's validating, again, each message against the predictions schema from Apicurio Registry. It's computing, as you saw in the terminal, it's computing real-time statistics from that information. And you're going to see statistics and things like agreement rate, and we are going to calculate the confusion metrics for the information, distributions, uncertainty zones. And all of this, and you're going to get more information about that, is happening in memory. And that's a bit about the presentation. And the Quarkus application is serving all of that through REST endpoints in this presentation and in this application. Some of the design decisions I had to make for this presentation are, I think, are worth discussing. The first one, and the most important one, is, as I was saying, is doing inference inside the Spark. Normally, in a production environment, in 2026, you wouldn't do inference inside the Spark, to be fully honest. But I'm running the models using UDFs rather than calling an external model server like TensorFlow, Serving, or Triton, or any other tool. Basically, because for this presentation, it's avoiding me having to deploy yet another thing into the presentation. It's also avoiding, for a system like this, it's also avoiding, obviously, network latency for every prediction. And it keeps the pipeline simple. There is no separate service to deploy. The trade-offs is that, obviously, the inference is coupled to the streaming framework to Spark. Excuse me. And the biggest trade-off in this case is, obviously, if you need to update a model because you retrained your model, you need to rebuild the image that you're running in a Spark, and you need to redeploy that image for obvious reasons. But I think for this pipeline, simplicity wins, and I think the pipeline is simple enough, and you can use it. Another important thing is that the in-memory analytics for a presentation like this are good enough, and I'm serving them through a REST endpoint, so you can still glue something in there. But obviously, in a production environment, you will persist that to a time series database like InfluxDB, TimescaleDB, any kind of technology of your choice or preference. Okay, I wouldn't recommend having your statistics and your information in memory in production. Just saying. So third, I had to register we registered the schemas in Apicurio Registry before any data flows. That means that on one hand, every component can evolve independently. The producer, the consumer, everything can evolve independently. But at the same time, there you have network latency, and it's one of the reasons why I didn't want to add even more network latency. Okay, so you have the network latency on this side. But honestly, in practice, having and being able to evolve your different components independently, I think it's really, really huge, because the team that is developing this producer is very simple, and also the consumer is quite simple. But in an enterprise scale, the producer and the consumer wouldn't be that simple. And those teams can work independently without even coordinating between themselves about what one is deploying in the producer side of things and in the consumer side of things. So that's an important thing. And the fourth and last in this part, the lazy model loading. Both models are being loaded in on first use. On first use, you are not seeing that because it's happening really, really fast, but they are being loaded on first use. It's critical, and it's a bit of a technical detail and a bit of an implementation detail. But if you need to serialize a neural network into a pickle, that does not work very, very well in a Spark. So it's a bit of an implementation detail, but I think it's also an important part. And now another important part that we have here are the dashboards. Essentially, we have 4 dashboards. The first one is going to be the dashboard. It's basically a counter. This first one is a counter. I have the culture, and you are seeing that the dashboard is evolving live on a stage. You're going to see that the number of posts for every category. You're also going to see the average confidence for every category. This is averaging the confidence for both models, not just one of them. Here you can see a model comparison between the confidence between the transformer and the scikit-learn model. And here you can see what I was discussing about confidence when it comes to the transformer model and to the other one. The transformer is always very confident about the things that it's predicting. It's always very, very, very confident, always. And then in this part here, we also have the agreement rate between the two different models. And this is where this thing starts getting interesting. Because for the categories where you have an agreement of almost 1 between the 2 models, fine, great. I'm doing great in this category. For those like personal or history where your agreement is not that great, those are the categories where you really need to get attention in your data and when you're returning your model. And the very interesting and important part about these last 2 dashboards is that you're getting this, I was going to say for free, obviously not for free, because you're running 2 models, but you're getting these insights because you're running the 2 models in production. With just the transformer model, fine, it's confident, great. I have my prediction. If you have the other model, I have some predictions, but I don't know if I can trust those predictions really. But with these 2 dashboards and with this information, you can start working with that and start doing more things. So I think that those 2 are the most important parts. And now, getting back into the presentation, I'm going to get into the confusion matrix dashboard. This one again is a very important one. In the diagonal, you have the agreement between the 2 models. Fine. For those posts that landed here, it's kind of the same thing. I'm happy with that. Then of the diagonal cells, then you have systematic differences. For instance, you might see that the transformer says that one post falls under the travel category, and on the other hand, the scalar model might say that it's culture or something like that. It tells you just not how often they disagree, but it tells you how they disagree, how both models disagree. And that's also critical for understanding how they are failing when they are trying to predict something. If you're building an active learning system of this, those off-diagonal cells are the ones that are telling you exactly which category pairs you need to pay your attention and where you need to work on your training data and on your labeling data. I'm going to skip this one because we are running a bit out of time. This one, I'm going to do it very, very quickly. It's basically telling you the confidence distributions for both models. As I was saying during the whole presentation, the transformer is very confident, so you have most of the posts from the transformer fall here. And obviously, the scaling model is distributed more evenly through the chain. And then I'm going to get into this part here, because I think this is the... If you leave this presentation with something, I want you to leave this presentation with this insight about this presentation. I think this is the most important takeaway from these dashboards. This chart divides the confidence agreement between the two models into 3 separate zones. Green, great. Both models are agreeing, and we are happy. Orange, both are don't know what they are really trying to predict. And these disagreements cases here in red are exactly the post you need to send for manual review or use, as I was saying, for active learning to improve your models and to improve your data. Those are the posts you really need and you really want to get attention. And in case you were wondering in my schemas why I was sending the IDs of the post in the whole flow, that's exactly why. Because you need those IDs to get back to those posts and then get that data and see what's going on with that data. If you get to this point, great. They are disagreeing, and I have this thing here. Great. And now what? There's nothing I can do with this data here, right? And now, getting back to the presentation. Just a little bit I've been doing this a little bit also during the presentation. There are a few things to be taken into consideration for production. You need to apply classical design patterns like dead letter patterns for your Kafka topics. Obviously, backoffs, jitters, circuit breaker patterns. Obviously, you need to apply all those patterns. When it comes to observability, you need to apply things like, instead of having an HTML like me in my presentation, please have something like Prometheus, Grafana for your metrics, Jaeger for tracing your requests and your Kafka messages. Please don't be like me and apply your patterns properly in production. This is the last part of the presentation, and you're going to get the code, and this is very important because this is just a pattern. The pipeline you've seen here is just a pattern. You can apply the same pattern really to any raw data that you have, IoT, Twitter, or exposed, any raw data that you're dealing with and you're trading, you can apply exactly the same pattern and exactly the same pattern to your data. And we are running a bit out of time. The conclusions are the ones I was discussing here a little bit, and I want to give you the opportunity to ask any questions in case you have them. Please. I think we have a microphone. We have a couple minutes just, and I don't want to take the. Please.
Thank you for the detailed presentation. I'm working on something similar, running workflows on the Kubernetes. Just a TLDR of what I understood. You are taking the stream, kind of stream-like data, but now you have CV. So you are kind of doing data preparation and data cleaning, preparing the data set. Then you are passing that data set into producer, which in turn is passing that into Apache Stream. That's a message queue for inference, on which the dual inference is happening. First, that data is textual, so I'll come back to that. And then that inference data is taken by the consumer, and it is partitioned into different categories, like you mentioned. So Kubernetes, on the, if we see, it is for the scaling of both producer and consumer as the data from the stream or the CV set grows. Is my understanding correct?
Yes, for sure.
OK, so if we have, say, for the real-world examples, actual streaming data, suppose like vision LLMs, something like you are monitoring a conveyor belt, or you are monitoring something food-grade production level. How do you think those dual inference models we have selected, you mentioned it's a choice, But do you think they will be able to properly classify the data then if the sizes are increased?
At some point, there are multiple ways of scaling your infrastructure, for sure. Kubernetes is just one of them. But nowadays, frameworks like, I think I need to remember one of them is the name. Ray is one of the frameworks, multiple frameworks for scaling the infrastructure, also for inference and on Kubernetes are evolving and appearing continuously. Ray, for instance, is one of them. It has Ray serve for serving models in production.
You mean Ray by any scale?
Yes.
Okay.
Yes, for sure. Yes.
Thank you so much.
Absolutely.
Definitely more questions.
Sure. Any more questions? No? Thank you very much.